All right, let's go over the final unit, Unit 9, redox. This should be the most familiar to you since we covered this the last. So yeah, let's get into it. Question 1. Determine the oxidation number of chromium in H2Cr2O7. So based on our rules of redox, we know that oxygen has a 2 minus charge. Same for hydrogen, we know that is 1 plus. So based on this info, the whole compound H2Cr2O7 has a charge of 0. So in order to get this to a charge of 0, we can do this algebraically. So we have two hydrogen molecules, meaning we got to do 1 times the positive, or sorry, 2 times the positive 1. So that's 2 plus, and we have two of the Cr molecules that we don't know and we're looking for. So we're going to do 2x since there's two of this, same like the hydrogen. And since we have 7 oxygens, we're going to do 7 times negative 2, which is negative 14. And this all has to equal to a whole total charge of the compound of 0. Solving this, we plus 14 to this side, plus 14 to this side, and then minus 2 to both sides as well. So that gives us 2x, little arrow there, 2x equals 12. And then we divide by 2 on both sides algebraically, and we get x equals 6. And that is a positive 6. So therefore, the oxidation number of chromium is going to be 6 plus. Let's write that on top, 6 plus for chromium, and this is going to be our final answer. All right, let's take a look at number 2. In the reaction below, determine which element is oxidized and which element is reduced. All right, so automatically we know we have to refer to our handy dandy oil rig. Oil rig. And not only are we solving for the oxidized and reduced elements, we're going to go ahead and take it a step further and apply our learning to identify the oxidized or oxidizing agent and reducing agent as well. So let's make a little space for this on the bottom. We have let's color. We're looking for one oxidized element. We're looking for reduced element. We're looking for a oxidizing agent. And the reducing agent. All right, with this we can get started. So first off, with this reaction here, you want to identify all the oxidation numbers of everything inside. So for standalone elements, we know that the rule of redox says that these standalone elements all have a oxidation number of 0. For HNO3, we can go ahead and recognize that NO3 has a charge of charge of 1 minus. So, and we know the oxygen has a 2 minus charge. That's one of our rules. The charge of NO3 was determined using the periodic table we get in class, the common ion sheet on the back. So if you have 2 times 3, which is negative 6, and negative 6 plus n for this part only has to equal negative 1 for the total charge. That means our n has to be a 5 plus charge. So knowing this information, we can do a 5 plus on the n. And our hydrogen, we know that our rule says is 1 plus. Next, let's look at Sb2O5. Let's erase this part real quick, though. So we know that O is always a 2 minus, unless it's a part of a peroxide, but you do not need to know this for our test. So we have a negative 2 times 5, which is negative 10. And since there's two Sb molecules, we want to divide that 10 by 2. Let's solve this algebraically, though. So we have negative 2 times the 5 oxygen there is, negative 10, plus 2x, because there's 2 molecules of Sp. Erase that real quick, though. 2x has to be 0 in the end because our total compound charge is a 0. So add 10 to both sides, divide by 2 on both sides, and we get x equals 5. And that is going to be a 5 plus. All right, so we can erase that, and we know that Sb has an oxidation number of 5 plus. Let's write that a little better. 5 plus. All right, and very simple. We know that oxygen, its rule says it's 2 minus, and the whole compound charge is 0, but there's only one N. So in order to add something, some N, which is the nitrogen, we have to add N to negative 2 to make it 0. So N plus negative 2, well, I can write it N minus 2 equals 0. So then add 2 to both sides, N equals 2 plus. So we know that is 2 plus. Finally, our favorite, water. Oxygen here is 2 minus always, and hydrogen is always a 1 plus. And you can always double check by taking this 1 times 2, which is 2 plus, and it's just 1 here. It's an invisible 1, so it's a 2 minus, and this totals a net charge of 0. All right, so with this information, now we can evaluate which one's oxidized, reduced, which is the age and the both of the agents. So, taking a look at Sb first. Sb goes from a charge of 0 right here to the Sb5 plus right here. If you're going from a charge of 0 and you're going to a 5 plus, you're becoming more positive. In order to become more positive, you're losing electrons. So oil rig, you're losing electrons. Therefore, we know Sb is the oxidized. Oxidized. And if you are not familiar with oil rig still, oil rig stands for oxidation is loss of electrons, and reduction reduction is gain of electrons. So if you're gaining electrons, which is more negative, you're becoming more negative. But if you're losing electrons and electrons are negative, you're becoming more positive. All right. So we'll actually keep that there. So now we know Sb. Let's take a look at hydrogen here. Hydrogen still has an oxidation number of 1 on the reactant side and 1 on the product side. Therefore, we can completely ignore hydrogen when looking at our oxidized or reduced elements. All right, next, let's take a look at N. N has a charge of 5 plus, right here, 5 plus. The N here has a charge of 2 plus. So N, you're going from a 5 plus to a 2 plus. If you're going from a 5 plus, which is greater in positivity than 2 plus, you are gaining electrons because you're becoming more negative. If you gain electrons when you're 5 and you become 2, you're becoming more negative. Therefore, we know it is reduced. For our purposes, when you determine both of the oxidized and reduced elements, you basically know for almost a fact that you have found both of the components needed. So if we take a look at oxygen, it stays a constant 2 minus throughout our reaction, or the oxidation number stays constant. Therefore, these two elements are the only ones being oxidized and reduced, respectively. So let's enter A, which is oxidized. Well, we know that Sb went from 5 to a 5, or 0 to a 5 plus, becoming more positive, which is a loss of electrons, which is oxidized. So Sb is oxidized. Next, N. We know that N was reduced because N went from 5 plus on the reactant side to a 2 plus on the product side, therefore gaining electrons and losing its positivity. Therefore, we know that N is reduced. For oxidizing agents and reducing agents, we know that it's very simple to find this out. You take the oxidized element, and this goes to the reducing, and you take the reduced element, and this goes to the oxidizing agent. So with this information, we know that since Sb is oxidized, that is going to be our reducing agent, and we know that N is reduced, so it is going to be our oxidizing agent. And that is it.